Hey everyone, welcome back to my YouTube channel. Today we are solving a classic binary tree problem from LeetCode, finding the maximum depth of a binary tree. This is a very common coding interview question. So make sure you watch this video till the end to fully understand the approach and the code. And we can see here that the problem says we are given the root of a binary tree and we need to return its maximum depth. And the maximum depth is defined as the number of nodes along the longest path from root down to the farthest leaf node. For example, our input is given as 3, 9, 20, null, null and 15 and 7, and output should be 3. And for example 2, root is given as 1, null, 2 and output should be 2. And one way to think about it, and at each node the maximum depth is 1 plus max of depth of left subtree, depth of right subtree. So we just need to traverse the tree recursively until we reach the leaves. And here we will use DFS, that means depth first search recursion. And if the root is null, we will return 0. Otherwise, recursively we will calculate the depth of the left and right subtrees, and we will take the maximum of both and add 1 for the current root node. So now let's implement this problem. First of all, we will check if not root, then we will return 0. That means if there is no root, then we will return 0. Otherwise, we will define left underscore depth is equal to self dot max depth of root dot left, and then right underscore depth is equal to self dot max depth root dot right. Okay, and then again, and then we will return 1 plus max of left underscore depth right underscore depth. Now let's try run this example first. We have been given an input 3, 9, 20, null, 15, 7. And for node 3, we check left, that is 9, and right 20. And we can see that node 9 has no children, so that means its depth is 1. Now coming to node 20, it has children 15 and 7, so depth is equal to 1 plus max of 1, 1, and that is 2. So finally node 3 depth 1 plus max of 1, 2 is 3. So maximum depth is 1, 1 and 1, that is total 3. So that is our expected output. Here time complexity of our solution is big O of n, because we are visiting every node only once, and space complexity of this solution is a big O of h, where h is the height of the tree, because we are implementing a recursion stack, and in worst case it is big O of n for a skewed tree. There might be a solution where there is no left subtree and everything is on right, or there might be a problem where there is no right subtree and everything is on right. These are our skewed trees. So now let me try to run it and check if it works for these two test cases or not. As we can see, our solution passes these two test cases. Now let me try to submit it and check how does it perform compared to other users, and in terms of memory and time complexity. As we can see here that our code outbeats 30.95% of users in terms of time complexity and 78.65% of users in terms of space complexity. So that's how you solve maximum depth of a binary tree efficiently using recursion. And if you found this video helpful, do not forget to hit the like button and subscribe to my YouTube channel Geeky Words, and comment below which tree problem you would like me to solve next. Thank you for watching and see you in next video.